So one thing they also talk about in the papers, I'm not going to go through in a lot of detail, is if imagine that detecting people has a cost. I have to pay an audit cost A each time I detect someone. Like I have to go monitor them or whatever. Then these are actually real costs, and the government would like to not have to do very many audits. So it would like to discourage corruption with a low P. And so what they say is, well, you can do that because imagine the social cost is P times A, right? Because every audit you have to cost A. So by setting P to 0, I can discourage corruption at no social cost. But what does that mean? That means that I'm going to have to collect these huge payments up front from people for the job, because ex post they're getting these massive rents, right? So it's a little bit of a weird system where I set the wage really high, I collect all this money up front, but then, as they also point out, but then, once I've collected that, and then maybe the state might renege and sort of try to fire you because it's collected all this money from you, and now it wants to sort of it might want to keep your payment and get to fire you. So maybe that doesn't happen in practice. So here's the other cool thing you can do with this model. So now suppose that instead of having W be something the government is setting to keep you indifferent, let's fix W. Just make it set. Okay? But now, let's suppose the chance you're detected depends on how many other people are corrupt. Okay, so to be precise, let's denote C by the fraction of the population that's corrupt, and let's write down the probability that you're detected conditional on stealing is 1 minus C. Okay, so what might rationalize this story? Imagine there's a fixed number of prosecutors in the world. Okay? So if nobody's corrupt, right, these prosecutors are sitting in their office, they're super bored, they have tons of time on their hands. There's a corruption case, bam, that person gets nailed and goes to jail. Right, because all those bored prosecutors sitting around. Now imagine that there's the same number of prosecutors, but everybody is corrupt. There's a zillion corrupt people. They're totally overwhelmed. And for any individual person, the probability they get caught by the prosecutor is very small. Right? Because the prosecutors are totally overwhelmed with sort of the corruption workload. So does that argument make sense? And that justifies not necessarily this exact functional form, but something where sort of the probability of detection is declining in the fraction of the people that are also corrupt. Okay, is that clear? So now what happens? So recall in our model, the agent is going to steal if W minus V is less than 1 minus P over P times B. Okay, with this super simple functional form, I can rewrite this as W minus V is less than C over 1 minus C times B, because P is just equal to 1 minus C. Right, so I can just substitute. Right. So now I can graph these things. Okay, so this is C from 0 to 1. I put W minus V, that doesn't change. And then I just graphed C over 1 minus C times B. So why is that useful? So suppose we're in a world where nobody is corrupt. What's the equilibrium? Suppose C is 0. So no one's corrupt. What am I going to do? Am I going to be honest or am I going to be corrupt?
No one's going to steal.
No one's going to steal, right? You can see that because sort of, C over, W minus V is much higher than the sort of the C over 1 minus C times B. On the other hand, if everybody's corrupt, the way I've drawn this graph, everyone's going to steal. So now, with the simple modification of the model, we have two stable equilibria, right? One where everyone steals and one where nobody steals, and then we have this third equilibrium over here, which is unstable. Right? It's unstable because if you perturb it this way a little bit, it'll go down there, and if you perturb it this way a little bit, it'll go up here. Right? So we have two stable equilibria and one unstable equilibrium. Right? So this is a, in some ways, like rationalizes like the idea that I'm stealing because everybody else is. Right? Sort of says, look, I can get away with it if everybody else is also doing it. And that says, look, that can be an equilibrium of a very simple model. Is that clear? Okay. So now, another thing that's kind of interesting about this is, did I draw this? Oh, no. Okay. If you modify this model a little bit, so one thing about these equilibrium is they're persistent. So I'm not going to formally prove this, but if you imagine like a more dynamic version of this model, you could have a temporary corruption crackdown having a permanent effect if it switched to equilibrium. So imagine somehow I was able to I was able to temporarily add a ton of prosecutors. We're in the corrupt world. I temporarily have a big corruption crackdown. I say, look, for the next 6 months or whatever, we're going to prosecute everybody, right? So this curve is going to come way down here. People might shift to the honest equilibrium, right? And as long as you had as long as there was some notion of persistence, I could then say, well, now we're in the honest equilibrium, so I'm going to let go and go back to the old equilibrium, and now I can get by with a small number of prosecutors because we're in a better equilibrium. And so these temporary shocks can have the kind of these long-run effects. And I think that's something that comes up a lot in corruption, that there are these idea of these multiple equilibria. So that story is about probability of detection. I also told there are some stories about selection into the bureaucracy, right? Where somehow, sort of along the lines of the story I told a few minutes ago, where basically if I'm corrupt, I'm willing to pay more for the job, right? And that creates corrupt people in the bureaucracy. On the other hand, if there's no opportunities for corruption in the bureaucracy, then no one's going to be willing, the corrupt people aren't going to be willing to pay more to become into the bureaucracy. We'll have honest bureaucrats, and they won't be corrupt, and sort of it could be potentially self-fulfilling, being a little loosey-goosey there, but that's basically right. The story I told you before about the driver's license office, I think also can create multiple equilibria, right? Imagine the driving license person is in a world where every single person's giving him a bribe. He says, look, someone comes in the door, they offer me a bribe. I'm going to think to myself, what's the relative likelihood that that's someone actually trying to bribe me versus it's a cop trying to, catch me? If tons of people are bribing, it's probably a real person giving me a bribe, so I'll take the bribe. And if there are very few people who are taking me, it's probably a cop, right? And similarly, you can tell the story on the other side of the transaction as well. So that can also create these multiple equilibria. And the other one I think that can do it is enforcers, or who will punish the punishers. So what you often hear when you hear about corruption in developing countries is, a real problem is, they try to put someone in jail for corruption, and the corrupt official bribes the judge, right? And why does that happen, or bribes the prosecutor? Well, why is that an equilibrium? Well, suppose they tried to prosecute the judge for taking a bribe. Well, he'll bribe the next judge, and so on, right? And why would the other judge accept it? Well, because that judge thinks that if he was caught, he could bribe the next judge, and why would she accept it, and so on and so forth, right? So that's an equilibrium. There's also an honest equilibrium of that game, which is I try to bribe the judge. Judge says no, I'm not going to take a bribe. Why does the judge say no? It's because if she took the bribe, she wouldn't be able to bribe her way out of it to the next judge, and so on. And so that game can have multiple equilibria too. So I think what's kind of interesting about corruption is there are lots of reasons why you can get these multiple equilibria. We don't actually know as a matter of practical fact whether this is actually true that we have multiple equilibria in corruption. But it's certainly something that comes out of lots and lots of these models. That there could be two countries that are very similar in terms of their objective fundamentals, but one of them is really corrupt and one is not corrupt. And it's not necessarily because they're better people or something. It's just because they're in this better or worse equilibrium.